Good morning, students. Good morning, math enthusiasts. Today we are going to discuss about drill 2.6. But before that, it is very important that you have memorized the 6 trigonometric functions and their representations. So by SOHCAHTOA, sine theta is equal to y over r. Cosecant theta is the reciprocal of sine, so that you have r over y. Cosine theta is x over r, and the reciprocal of cosine is secant theta, which is r over x. Tangent theta is equal to y over x, and the cotangent is the reciprocal of tangent, which is x over y. Problem number 1 asks you to determine the 6 trigonometric functions given a particular point, which is P 8, 15. This implies that x is 8 and y is 15. So since r is unknown, we determine the value of r by using the Pythagorean theorem, which states that r is equal to the square root of the square of x plus the sum of the square of x and the square of y. By substitution, we have r is equal to the square root of 8 squared plus 15 squared equals 17. So our x is 8, our y is 15, and our r is 17. So by SOHCAHTOA, our sine theta is y over r. So y is equal to 15, our r is 17. Cosecant theta is the reciprocal of sine theta, so that cosecant theta is equal to 17 over 15. Cosine theta is equal to x over r. Our x is 8 and our r 17, so we have 8 over 17. Secant theta is the reciprocal of cosine theta, so we have 17 over 8. Tangent theta is y over x. Our y is 15 and our x is 8. And cotangent theta is the reciprocal of tangent, so cotangent is 8 over 15. What is the measure of angle theta? Well, that's going to be a next lesson. Letter B. We are given the point negative 5, 12. So x is negative 5 and y is 12, and by Pythagorean theorem, r is equal to 13. So sine theta is equal to y over r, so 12 over 13. Cosecant theta is 13 over 12. Cosine theta is equal to x over r. X is negative 5, r is 13. And secant theta is the reciprocal, which is 13 over negative 5. Tangent theta is equal to y over x. Y is 12, x is negative 5. So, cotangent theta is the reciprocal of tangent, so we have negative 5 over 12. Letter C, we have P equals, or P of 6 over 8, and negative 8. So, our radius, or r, is the square root of 6 squared plus 8 squared, which is, using our scientific calculator, equal to 10. So sine theta is y over r. Y is negative 8, r is 10. So we have negative 8 over 10, or negative 4 over 5 when simplified. Cosecant theta is 5 over negative 4. Cosine theta is equal to x over r, 6 over 10, or 3 over 5 when simplified. Secant theta is the reciprocal of cos, which is now 5 over 3. Tangent theta is equal to y over x, negative 8 over 6, simplified into negative 4 over 3, so that the reciprocal cotangent theta is negative 3 over 4. Letter D is P of negative 12, negative 5. So, to find r, we use the Pythagorean theorem and obtain r equal to 13. So, sine theta is y over r. So, negative 5 over 13. The reciprocal cosecant theta is 13 over negative 5. Cosine theta is x over r, negative 12 over 13. Secant theta is the reciprocal, which is 13 over negative 12. Tangent theta is y over x, so we have negative 5 over negative 12, or 5 over 12. Cotangent theta is the reciprocal of tangent theta, which is 12 over 5. In letter E, we are given the point 0, negative 4, so that the radius is 4. So, sine theta is equal to y over r, negative 4 over 4 is negative 1, and the reciprocal is also negative 1. Cosine theta is x over r, which is 0 over 4, which is equal to 0. The reciprocal of 0 over 4 is 4 over 0, which is undefined, so that the second theta is undefined. Tangent theta is y over x. You have negative 4 over 0, which is undefined, but the reciprocal of negative 4 over 0 is 0 over 4, so that cotangent theta is equal to 0. Letter F. Point negative 3 square root of 3, negative 3. So using the Pythagorean theorem, the radius is equal to the square root of the square of 3 square root of 3 plus the square of 3, which when simplified using a scientific calculator or manually, it's equal to 6. Sin theta is equal to y over r, which is negative 3 over 6, or negative 1/2 when simplified, so that cosecant theta is the reciprocal, which is negative 2. Cosine theta is x over r, so negative 3 square root of 3 over 6 is negative 3 square over 2, negative square root of 3 over 2, and the reciprocal secant theta is negative 2 over square root of 3, or negative 2 square root of 3 over 3 after rationalization. Tangent theta is y over x, negative 3 over negative 3 square root of 3, and when simplified is 1 over square root of 3, which is equal to square root of 3 over 3 after rationalization because of the presence of the radical sign in the denominator. The reciprocal of this is of 1 over square root of 3 is square root of 3, so that cotangent theta is square root of 3. Letter G. We are given the point 1 negative square root of 3. So r is equal to the square root of 1 squared plus the square of square root of 3, which is 2. Sin theta is y over r, which is negative square root of 3 over 2, and the reciprocal cosecant theta is equal to 2 over negative square root of 3, or negative 2 square root of 3 over 3 after rationalization. Cosine theta is x over r, which means 1 over 2, or 1/2. Secant theta is the reciprocal, which is 2. Tangent theta is equal to y over x, negative square root of 3 over 1, or negative square root of 3. Cotangent theta is the reciprocal, so that we have 1 over negative square root of 3, or negative square root of 3 over 3 after rationalization. Finally, the last letter of item 1, we are given P20, which implies that our radius is 2, because 2 squared plus 0 squared is 4, square root of 4 is 2. Sin theta is y over r, which means 0 over 2 equals 0. The reciprocal of 0 over 2 is 2 over 0, which is undefined, so that cosecant theta is undefined. Cosine theta is x over r, so 2 over 2 equals 1, so that secant theta, the reciprocal, is still 1. Tangent theta is equal to y over x, 0 over 2, which is 0, but the reciprocal of 0 over 2 is undefined, or 2 over 0, which is our cotangent theta. We will now proceed to item 2, wherein you will be given one function and you will be asked to determine the remaining 5 functions with the addition that any other function may be stated there. For example, you are given that sin theta is equal to 5 over 13 and cosine theta is positive or greater than 0. When we say it's greater than 0, that means we are referring to a positive value. So cosine theta is positive. Now we will apply our knowledge in sukrita. Sukrita, again, if you may recall, is sine is positive in upper quadrants, cosine is positive in right quadrants, and tangent is positive in alternate quadrants. With regards to the reciprocals, whatever ang property sa atong sine, cosine, tangent, the same ra si cosecant sa sine because it is the reciprocal of sine, the same ra po si secant because it's the reciprocal sa cosine because it's the reciprocal of cosine, the same ra po si cotangent sa tangent because it is the reciprocal of tangent. Now from sukrita, it says that cosine is positive in quadrant 1 when sine is positive in quadrant 1? Yes, cosine is positive in quadrant 1 when sine is positive. Take note that sine is positive in upper quadrants 1 and 2, and cosine is positive in quadrants 1 and 4. So their intersection or their common is the quadrant 1. Okay, so from there, we are going now to derive sine theta equals 5 over 13 is defined as y over r. Therefore, y is equal to 5 and r is equal to 13. So, your unknown is x. So, we derive our Pythagorean theorem so that it becomes r squared minus y squared. So, 13 squared minus 5 squared is equal to 12 using our scientific calculator. So we already have the values of x, y, and r. So sine theta is equal to y over r, which was given. And the reciprocal of that is cosecant theta, which is 13 over 15. Of 5. Sorry, that's 5. Okay. Cosine theta is equal to x over r. Our x is 12 and our r is 13, so that cos theta is 12 over r. The reciprocal of 12 over r is 13 over 12, which is our second theta. Tangent theta is y over x. So we have 5 over 12 and the reciprocal is 12 over 5, which is cotangent theta. In letter B, we were given that cos A is equal to 3/5 and that sine A is positive. So remember in Sukrita that sine is positive in upper quadrants 1 and 2 and cosine is positive because that's 3 over 5, so it's a positive sign in quadrants 1 and 4. So the intersection is in quadrant 1. So sine A is positive and cosine A is also positive in quadrant 1. So using cos A equals 3/5, cos A is defined as x over r, so that x is equal to 3 and r is equal to 5. Using this Pythagorean theorem, so we have 5 squared minus 3 squared because r is given and y is unknown. So using our scientific calculator, it's equal to 4. Now we will substitute. So sine theta is equal to y over r 4/5. Cosecant theta is the reciprocal 5/4. Cosine A is 3/5. Reciprocal is 5/3, which is secant A. Tangent A is y over x, 4 over 3. Reciprocal is 3/4, which is cotangent A. Letter C, we were given cosine B equal to negative 4/5 and sine B is positive. So by Sukrita again, sine B is positive in upper quadrants 1 and 2 and cosine is negative in quadrants 2 and 3 or left quadrants. So the common is quadrant 2. So sine B is positive in quadrant 2 and cosine B is negative in quadrant 2. So we will use this equation again or function. So cos B is equal to negative 4/5 is defined as x over r. Therefore, x is negative 4 and r is 5. To find y, we have the square root of 5 squared minus 4 squared, which is 3. So we now have the values of x, y, and r. So sine B is equal to y over r, which is 3 over 5. And cosecant is the reciprocal 5 over 3. Cosine B is equal to negative 4 over 5. The reciprocal is 5 over negative 4. Tangent B is y over x, which is 3 over negative 4. And cotangent B is the reciprocal negative 4 over 3. So I guess this time you have already memorized x, y, and r. Okay, so letter D, sine alpha is equal to negative 12 over 13 and cosine alpha is positive. By sukrita again, cosine alpha is positive in quadrants 1 and 4, and sine theta is negative in quadrants 3 and 4. Therefore, the common quadrant is 4. So, cosine alpha is positive in quadrant 4 when sine alpha is negative. So, we use this equation function again so that sine alpha is defined as y over r, so that y is negative 12 and r is 13. So, we have placed the negative sign in 12 because y is negative in quadrant 4 and r is always positive. So, we find x by using the Pythagorean theorem. 13 squared minus 12 squared. You don't have to write the negative because whether it's negative or positive, the square is always positive. So, using your scientific calculator, the result is 5. So, we now substitute sine alpha is negative 12 over 13. Its reciprocal, negative 13 over negative 12. Cos alpha is 5 over 13. And its reciprocal, 13 over 5. Sorry. So again, that's 5. And that's not 15. Okay. So, tan alpha is equal to the opposite side over the hypotenuse. I mean, adjacent. Y over x. Negative 12 over 5. Cot alpha is the reciprocal, 5 over negative 12. Okay, letter E, we were given that tan beta is 15 over 8 and that second beta is negative. Okay, so when we think of the reciprocals, we go back to the basic functions. So second theta is the reciprocal of cosine theta, and cosine theta is negative, negative in quadrants 2 and 3. Tangent is positive in quadrants 1 and 3. So the common quadrant is 3. So, tangent beta is 15 over 8, which is y over x by definition. And so, y is negative 15 and x is negative 8. They are both negative because we are in quadrant 3. R is always positive, so by the Pythagorean theorem, R is 17. And by substitution, these are now the function values. Okay, letter F, we are given that cotangent phi is 4 over 3 and cosecant phi is negative. So again, cosecant phi is based upon the sukrita of sine. So sine is negative in quadrants 3 and 4, but cotangent is positive in quadrants 3 and 4, just like the tangent. So the common quadrant is 3. So using this function again, which is defined as x over y, so x is negative 4, y is negative 3 because we are in quadrant 3. By the Pythagorean theorem, r is equal to 5. Since we already have the values of x, y, r, then it would be easy for us now to substitute in our 6 definitions of the 6 trigonometric functions. Letter G. We were given cotangent theta is equal to negative 5 over 12 when cosecant theta is negative. Cosecant theta or sine theta is negative in quadrants 3 and 4. Cotangent or tangent is negative in quadrants 2 and 4. So the common quadrant is 4. So cotangent theta is equal to negative 5 over 12 is defined as x over y. So since we are in quadrant 4, our x is positive and our y is negative. So this must be wrong. Because in quadrant 4, our x is positive and our y is negative. So that our rate r is equal to 13 using our scientific calculator. So we now proceed with our substitution because we already have the values x, y, and r. So these are the trigonometric function values. Letter H. We are given tan A is equal to negative 8 over 5 and secant A is negative. Secant A or cosine A is negative in quadrants 2 and 3. Tangent is negative in quadrants 2 and 4. So the common quadrant is 2. So, using tangent A equals negative 8 over 5, it's defined as y over x, so that in quadrant 2, y is positive and x is negative. So, y is equal to 8 and x is negative 15. Using our Pythagorean theorem, r is equal to 17. So, since we have the values of x, y, and r, then we can now proceed to substitution of these values. Just do not forget to write or take with you the negative sign because we are in quadrant 2. Letter I gives us cosecant theta equals negative 2 and cotangent theta is positive. By sukrita again, cotangent theta or tangent theta is positive in quadrants 1 and 3 and cosecant theta is negative in quadrants 3 and 4. So the common quadrant is 3. Taking cosecant theta equals negative 2 is understood to be negative 2 over 1. And cosecant theta is defined as r over y, so that r is equal to 2. 2 is positive because r is always positive, and that y is negative 1, the negative. So x, using our Pythagorean theorem, x is square root of 3, but we write negative because we are in quadrant 3. So our x is also negative. So by substitution of these values, we have the 6 trigonometric functions. So again, do not forget to bring with you the negative signs because we are referring to an angle measure that is in quadrant 3. J. You were given that secant B is equal to square root of 2 and cotangent B is positive. Again, by sukrita, cotangent and tangent is positive in quadrants 1 and 3. So that secant theta also is positive in quadrants 1 and 4. So their intersection or the common quadrant is 1. So using this function, square root of 2 is understood to be square root of 2 over 1, and since secant B is defined as r over x, then r is square root of 2 and x is 1. So using our Pythagorean theorem, y is also equal to 1. So by substitution, we have these 6 trigonometric functions, including what we were given. Letter K, we were given tan alpha equals negative 1 and that sine alpha is positive. By sukrita, sine alpha is positive in quadrants 1 and 2. Tangent alpha is negative in quadrants 2 and 4. So the common quadrant is 2. So tan alpha is understood to be negative 1 over 1, which is defined y over x. So since we are in quadrant 2, our y is positive and our x is negative. So we write the negative in x. Our r is always positive, and by the Pythagorean theorem, r is square root of 2. So we now proceed with the substitution of our values. So y is 1, r is square root of 2, so we have 1 over square root of 2, which of course can be written as square root of 2 over 2 because this is not a final answer if the denominator has a radical sign. So we do rationalization. The reciprocal of 1 over square root of 2 is square root of 2. Okay, so I think that follows with the rest. And finally, we have the last item. So cosecant beta is equal to negative 1/2 when tangent beta is positive. Again, by sukrita, tangent is positive in 1 and 3 and cosine is negative in 2 and 3. So the common quadrant is 3. So cosine beta is equal to negative 1/2, which is x over r by definition. So x is negative 1 and r is positive because r is always positive. And x is negative in quadrant 3. By the Pythagorean theorem, y is equal to square root of 3 and square root of 3 is negative because we are in quadrant 3. So we have the values of x, y, r, so we are now ready with our substitution of the 6 trigonometric functions. Just do not forget to rationalize if it is required, or of course it's important to do so. So these problems were actually taken from the book of Leithold in Algebra and Trigonometry, and also from the book of Sham's Outline in Trigonometry. So that's all for today. Thank you very much. Remember, Math is easy to learn when one learns with enthusiasm. Bye!